Hello again, 7th graders, and once again, I'm coming to you from my iPad, and I'm just going to record today's lesson once again. I'm going to scroll through these exercises. We're going to go all the way up through exercise 82 today. A number of them are proofs. In this video, of course, you'll actually see what to fill in for these blanks. 69, by the way, that was one of these exercises where it's a drag and drop proof. How did you do with that? Yeah, hopefully you're able to figure out most of it. As you can see, I had some of it filled in for you. Now I've got it filled in all the way. But in today's work, we're going to be talking about ordered rings and ordered fields and solving inequalities with those, using those properties. And luckily, most of it you already know, honestly. When you take a look at these properties, it should be pretty intuitive for you. You should understand it, that when I've got two negative values, two items that are, less than 0 on this, like you see on, for instance, number 10 right here, right? Yeah, two negatives, obviously multiply them together. Yeah, it's going to be positive. And obviously they're both positive. That's going to be the case as well. Anyway, so again, and that's just review of properties of positive and negative numbers that you're already familiar with. When I'm talking about rational numbers, if I've got a pair of positives, they multiply to be positive. The pair of negatives multiply to be negatives, and so forth. And they talk a bit about the proofs here. And then this one, I went ahead and filled this in. This would have been something we would have talked about in class and filled in the blanks had I been there. But instead here, I've written it in for you. So this is your exercise 70. It's the proof of ordered ring property 12. So yeah, so we're always showing that no matter what the value of A is, as long as it's not the 0 element, when I square it, it's got to be greater than 0, or a positive element, if you will. And this just goes through the proof of ordered ring property 13. And on 71, these statements, again, because the whole thing about trichotomy is still a thing. It can be one of three things. A can be less than B, it can be greater than B, or it can be equal to B, but never all three. So, and again, this just applies trichotomy for this proof. I'm just filling on these properties, and it just extends properties 9 and 10 to conclude, yeah, 0 is less than A times B, and each of these is impossible in light of trichotomy, and so the assumption holds that A times B is less than 0 on this one. Okay, moving ahead. As we see on exercise 72 here. And again, this would have been another one we would have completed in class together, but that's okay. Just go ahead and take a look here. About again, we're checking out, what's the deal in case if we're dealing with the case where A is equal to B or B is less than A, and we show a contradiction against trichotomy in both cases to conclude A is less than B, in fact. Good. Okay, so again with solving inequalities on integers, the field of integers, ordered field, ordered ring. Let's get it right. So we're not dealing with a field here. Integers is not a field, it's a ring. Fine. So 3x plus 2 is less than 13. We can solve this out, and we get t is less than -5. And of course, on our number lines, as I mentioned yesterday, we, if I'm just doing an integer number line, I'm not actually shading -5. First thing I shade is -6, and so forth. Exercise 73. This one we can walk right through here. 4x minus 7 is less than 41. We find, using our usual steps of the equation solving, applying it to inequality solving, I get x is less than 12. So I should have an empty space here at the 12, and I fill in all these dots going on down the line to the left with the bent arrow. Good. I'm going to leave 75 for you to discuss with a classmate. Got the last couple of steps in here for you. Again, this is a proof for you to do with your classmates, and this is to show that that I've got a ring with 0 divisors. Remember, that changes things, right? If I have a ring with 0 divisors, I'll never have a field, by the way. And we're going to show that this, if I have a ring with 0 divisors, I cannot have ordering on it. This should, by the way, be one of those things that's pretty intuitive because, for instance, if I had mod 8, consider, z sub 8, right, kids? This most assuredly has zero divisors. And by zero divisors, I mean I can take 2 times 4 at mod 8 and I get 0. Why are those called zero divisors? Because quite literally I found 2 factors that multiply to make 0. Thus 0, you know, things that aren't 0, by the way. Don't just say 2 times 0 is 0. No, no, no. I can do 2 times 4 to make 0. Understand? Hope you understand that. Okay. So again, when you extend this out a little bit further, I mean, just start thinking about it here. You can create, if I had a mod 8 inequality here, this I can give you an example that's not an ordered ring, but you're going to come up with a generalization here. But permit me to show you an example. So, for instance, I think you would agree, for instance, that, well, let's not use 2. Let's say this. How about 1? Yeah, that's right. Yeah, let's do 1 is greater than, or sorry, 1 is less than 4, right? Yeah, that's of course it is. Don't be silly, right? Okay, fine. If I multiply both sides of this by 2, look what I get. I've got 2 is less than 0. See the problem? That's why you're going to, that's going to be a nice little demonstration of why if you have 0 divisors on the ring, you don't have an ordered ring, okay? Now complete a proof of that in exercise 75, please. Okay, moving on down, we go down now to ordered fields. So yeah, everything that extends, when I have a field of equations, I can now have a field of inequalities, and these properties are all going to carry over. And I will leave for you ordered field property, which incidentally, ordered ring properties must extend to the ordered fields as well. But these properties here don't necessarily follow on rings, okay? Not the least of which, because rings, I don't have invertibility on the multiplicative side of it. Okay, so exercise 79 I filled in for you, and so I have with exercise number 80, all right? Moving on down here, the proof of ordered field property 22, and again, this is just showing that if I've got products like this, if 0 is less than b times d, then a over b is less than c times d only if a times d is less than b times c. And that's that cross multiplication again. See? So easy enough. All right. And exercises 81 and 82 are just comparing. You're choosing less than, equal, or a greater than. Okay. I mean, obviously, there's some things that should automatically. I mean, whenever you see like D, for crying out loud, you shouldn't even have to think about it. I have a positive number. Positive numbers are always going to be the larger of the two. Understand? Good. So I will leave these to you to do on your own. You're going to complete all the way up through exercise 82. Kids, my plan is to start the test by next Friday. Okay? Hopefully everybody's up to speed by then. Hopefully you're staying caught up on your exercises. Thank you to those of you who have been staying up on your exercises this week. Eventually, I promise I will come back. Okay? It's just not today. So, hope you're being good for the sub, and have a great weekend, and I'll see you soon. Bye now.